And in today's episode, among other things, you'll see this. Scientists have started to simulate the entire human brain inside a supercomputer. We'll also see living robots that already have a nervous system and are starting to develop their own behavior. Amazon is now fully entering the race to put humanoid robots in our homes. In addition, we'll also see machines that are already running at speeds very close to Usain Bolt's, almost beating him. And a Chinese technology that has just surpassed the speed of sound right here on the ground. Let's make sense of all this and a few more things in the world of new technology. Hello, amazed viewers. I'm Carlos Alves, and you're watching Amazing Reality. There is a question that science still hasn't been able to fully answer. How does the human brain really work? And maybe the most amazing thing about all of this is the following. We use it every day, but we don't fully understand how it creates thoughts, memory, consciousness, and even our very perception of reality. But now a group of scientists has decided to try something that until recently seemed impossible: to simulate the entire human brain. Researchers at the Jülich Research Center are working on a project that aims to digitally reproduce billions of neurons functioning at the same time. And for that, they are going to use the world's most powerful supercomputer, Jupiter. This is a machine capable of processing gigantic amounts of information in parallel. But for us to understand the size of this challenge, we need to look at a much smaller example. Recently, scientists managed to completely map the brain of a fruit fly. And even though it's tiny, it has about 54 million neural connections. And all of that is concentrated in a space the size of a grain of sand. Now imagine scaling that up to a human brain. We're talking about something like 20 billion neurons just in the cortex, connected by around 100 trillion synapses. And even with all the computational power available today, that's still an extreme challenge. The researchers' idea is to combine several smaller models of brain regions and integrate them into a single simulation running at the same time, as if they were reconstructing the brain piece by piece, like assembling a Lego set. And there's an interesting detail here. Previous simulations carried out over the past decade failed to reach this level of complexity. And this happened even with huge investments. But now, with the advancement of supercomputers, something has changed. Scientists have already managed to demonstrate that large-scale neural networks do indeed start to show different behaviors. Not just bigger, but qualitatively different. It's as if upon reaching a certain level of complexity, the system starts to display properties that didn't exist before. And this raises an intriguing possibility. Could simulating an entire brain at full scale reveal something we've never been able to observe directly? Well, the answer to that question will have to wait for a while. But there's an important limit here. Even if this simulation works, it still won't be a real brain. According to the researchers themselves, simulating doesn't mean recreating, because the brain is not just a network of connections. It's influenced by chemistry, the environment, the body, and experience. And all of that is extremely difficult to reproduce. Even so, the journey has already begun, my friends. And it points to a future where maybe we can observe the workings of the human mind in a way never before possible, and maybe even answer questions that have accompanied humanity for several centuries, like the origin of consciousness or what it really means to think. But understanding the brain is just one part of the challenge, because while some scientists are trying to simulate how it works in machines, others are taking a much more direct path, trying to recreate systems that are already born with their own behavior. Yeah, let's take a look at that now. Yeah, we've seen that scientists are trying to simulate the human brain with increasingly powerful supercomputers. But there's another line of research that takes a completely different path. Instead of trying to reproduce the mind digitally, these researchers are now starting to build living systems capable of developing behavior on their own. Researchers at the WISE Institute have created a new type of robot, which is not made of metal or traditional circuits, but of living cells organized in a controlled way, giving rise to structures called Neurobots, which represent an important leap compared to the so-called biobots or xenobots developed earlier. The difference is that now these systems not only move, they also have something that didn't exist before in this type of structure: a functional nervous system that is capable of directly influencing behavior. These neurobots are formed from embryonic frog cells, which during development receive neural precursor cells. And over time, these cells differentiate into neurons. They start to connect with each other, forming real neural networks that begin to interact with the rest of the biological body. This detail completely changes everything, because in previous models, movement happened in a much simpler way, without central coordination, basically guided by physical mechanisms, whereas now there is an internal system capable of organizing and modifying this behavior. In practice, the researchers observed that the presence of these neurons changed not only the movement, but also the very shape of these structures, making the neurobots more elongated, more active, and with more complex and spontaneous behavior patterns. This indicates that the nervous system is not just present. It is functioning and influencing decisions and reorganizing the very bodies of these beings. The tests carried out reinforce this idea, because when the scientists applied substances that affect communication between neurons, the neurobots reacted differently from the models without a nervous system. This confirms that this neural network is active and playing a real role in behavior. But perhaps the most intriguing point goes beyond movement. During the experiments, the researchers identified changes in the gene expression of these structures, including genes linked to the development of sensory systems, which opens up the possibility that in the future, these systems could develop even more complex ways of interacting with the environment. This puts this technology in a unique position, because it stops being just engineering and starts to occupy a space between biology and machine, creating a new category of systems that don't fit completely into either one. And now we're going to leave these biological machines and enter the field of silicon machines. We're already used to it. It's a more familiar field for us. The race for humanoid robots has just gained a major new contender. And this time, it's not a startup or a research lab. It's Amazon. The tech giant has acquired Fauna Robotics, a company specialized in the development of humanoid robots, with an approach that's completely different from what we usually see out there. Instead of rigid, metallic industrial machines, Fauna developed a robot called Sprout, which takes an approach much closer to the human environment, standing about 1 meter tall and weighing just over 20 kilos. Sprout was designed to operate in shared spaces with a soft, foam-like body. This system prioritizes safety and interaction. This type of design isn't just aesthetic, okay? It completely changes the way robots can be used, because it allows direct interaction with people, even in home environments, without any of those risks associated with rigid and heavy structures. And this reveals something important about Amazon's strategy. Until now, the company had been focusing heavily on logistics automation, especially inside its distribution centers, with its very aggressive large-scale automation goals. But in the home market, its initiatives were still quite limited. Now, with the acquisition of Fauna, the focus is starting to change. The idea is no longer just to automate internal processes, and it starts to explore the potential of these humanoid robots aimed directly at the consumer. Amazon had already been investing in the development of artificial intelligence applied to robotics, especially through its internal teams focused on generalist systems. But they were missing something essential: the body. With Fauna, the company now has access to a physical platform that has already been developed, equipped with interaction systems and object manipulation, and the ability to learn over time. Let me tell you something new that I truly believe will really help you. Do you remember Aurea, the AI I've been talking about here on the channel for quite some time now? Well, now the folks at Genesis are now offering a 15-day free trial, okay? You don't need to use a credit card or any other payment method to register. It's really simple. Access the link in the description, pinned comment, or scan the on-screen QR code to go directly to registration. You can use it for half a month. Did you hear that? Half a month of full access to our AI. Do you know why these guys are offering this 15-day free access that no one else does? Because they trust the product they have. They know that once you try it, you'll want to use it indefinitely. And I want to remind you that with Aurea, you have access to the best AI models on the market: GPT, Gemini, Gypsy, and many others. Go check the pinned comment and see all the AIs available for you. And it's completely free for 15 days. This offer is just for those using my coupon. The link's in the description. This is thanks to Realidade Impressionante. So help us, and I'll keep helping you. Help me and I'll help you. In the United States, IHMC is preparing the next generation of its humanoid robot called Alex. And this time, the focus is no longer on impressing with isolated demonstrations, but rather on building a machine truly capable of operating in real-world scenarios, where every decision needs to be made in real time. This robot is the evolution of a previous model. It was already known for tasks like playing ping pong and even practicing boxing. But the approach has completely changed now. Less demonstration and more practical usefulness, with the design aimed at environments where humans would face very high risks. One of the most important changes is in the machine's body itself. It became lighter, faster, and more efficient, weighing about 85 kilograms, including the battery, a major reduction from the previous generation. And that's not just a technical detail. Why? Less weight means more agility, better balance, and greater adaptability in unstable environments. In addition, Alex was equipped with more powerful and precise actuators, allowing for faster and more controlled movements. This greatly expands his ability to perform complex tasks, especially those that require immediate response and changes in the environment. But the main point here is not just about performance, it's about purpose. Alex is being developed to operate in situations where human presence could simply represent a risk, like entering collapsed buildings, exploring dangerous areas, or carrying out reconnaissance missions before rescue teams arrive. And this completely changes the logic of using these systems. Because it's no longer a simple replacement, it becomes an extension of human capability. This type of robot is clearly being designed to operate together with people, adjusting its behavior based on the environment and human decisions, creating a coordinated way of working, which can transform sectors such as industry, logistics, maintenance, and emergency operations. And of course, when we talk about humanoids, we can't help but mention Unit Robotics. We'll see it soon. But first, check out this little robot here. It's linked in the description. I have to show it so YouTube allows the links. There's this one and there's this one here. There's C3PO. I'll leave the links in the description. If you buy through there, you help me out with a small commission, all right? Go check it out, take a look there. The one mentioned back there, the Chinese startup Unit Robotics, they presented a new demonstration of their humanoid robot H1, which reached a speed of up to 10 meters per second, which is equivalent to approximately 36 kilometers per hour. This number puts the robot much closer to the speed of a high-level human athlete. Usain Bolt, for example, ran 9-point-something. Can someone confirm in the comments? Something that until recently seemed pretty far off for this type of machine. For comparison, this speed is equivalent to running 100 meters in about 10 seconds. This performance, as I mentioned, is nearly at Usain Bolt's level. What's most impressive is that this breakthrough wasn't due to a major hardware change, but mainly from improvements in software and control systems. The H1 already existed, but now it moves much more efficiently with better coordination and at greater speed, showing that the evolution of robotics is increasingly linked to the intelligence that controls the body, and not just the physical structure of the machine. Weighing about 62 kilograms and with legs approximately 80 centimeters long, the robot was designed with a focus on dynamic performance. It is capable of handling fast movements and maintaining stability even at high speeds. This type of control requires an extremely high level of precision, because with each step, the system needs to adjust balance, force, and direction, all in real time. Any mistake can result in a fall, and that makes this achievement even more significant. When you look at the recent history, the leap is even more evident. At the beginning of 2024, for example, that same model reached about 0.3 meters per second. Now it exceeds 10 meters per second. That's an increase of more than 200% in a short time. And this kind of evolution shows that the pace of humanoid robotics development is really accelerating significantly. But speed alone is not the ultimate goal, it's an indicator, a sign that these systems are becoming more stable, more efficient, and more capable of operating in real environments. Because running fast, this one isn't just about speed. It's about control, it's about balance, it's about responsiveness. And all of these are essential elements for humanoid robots to be able in the future to perform much more complex tasks. But not all evolution is about speed, because in many scenarios, the challenge isn't to move faster, it's surviving in environments where humans can't enter. One of the biggest challenges in fighting fires isn't just putting out the flames, it's understanding what's really happening inside them. Environments with extreme heat, dense smoke, and constant risk of collapse. They make it almost impossible for a human to enter safely and come out alive. But a new technology is being developed precisely to change this scenario. Researchers at MPA have created a drone designed to operate directly inside fires, withstanding temperatures that would destroy any conventional equipment. Called the Fire Drone, this system was developed to withstand temperatures of up to 200 degrees Celsius. This is a huge leap compared to the approximately 40 degrees Celsius that traditional drones can withstand. This was only possible thanks to an advancement in the material that protects its components. The drone is covered by a layer of aerogel, an extremely light and porous material that can efficiently insulate heat, creating a thermal barrier around its entire structure. In addition, the system features internal temperature control, which constantly monitors its components and activates cooling mechanisms when necessary. This allows it to remain operational for several minutes, even in extreme environments. Equipped with cameras and thermal sensors, the fire drone transmits images in real time. This allows external teams to see what's happening inside a fire with great accuracy. This includes identifying heat sources, mapping internal structures, and assessing risks before anyone needs to enter the site. Another important detail is that the drone was designed to operate in environments where GPS is not working. It does this by using internal navigation systems that allow for precise maneuvers, even in enclosed spaces with no visibility. This greatly expands its range of uses, from rescues in burning buildings to inspections at industrial facilities that remain dangerous for days after the fire. And while some technologies are being created to protect lives in extreme situations, others are being developed to push boundaries that seemed unattainable for decades. You'll understand. Stay here and you'll understand. Researchers from the Chinese Academy of Sciences have developed an electromagnetic launch system that is capable of accelerating vehicles to supersonic speeds right here on the ground, surpassing Mach 1. That's equivalent to more than 1,200 km/h. This type of technology, known as an electromagnetic sled, had already been studied decades ago by countries like the United States and even the former Soviet Union. But it always faced technical limitations that prevented its reliable use at such high speeds. The main challenge was not just accelerating the vehicle, but maintaining control. At speeds close to or above the sound barrier, the system starts to face aerodynamic forces that are extremely unstable, as well as shock waves, which can directly interfere with the sensors responsible for measuring speed and position. In practice, this means that the system itself loses the ability to know how fast it is going, which makes any mistake potentially catastrophic. The solution found by the Chinese scientists was to completely eliminate this dependence on external sensors. Instead, the system started to extract information directly from the electrical behavior of the coils that propel the sled along the track. As the vehicle accelerates, small variations in the voltage of these coils carry precise information about speed. These signals are analyzed by an algorithm that combines multiple readings. It filters out the interference caused by shock waves and adjusts the data in real time. The result is a system capable of measuring speed with an error of less than 0.1%, even at speeds over 370 meters per second. This level of precision allows something that was previously impossible: stable control in supersonic conditions. This suggests the study of this technology. It may be just the beginning of something even bigger. A new type of infrastructure capable of operating at speeds that, until recently, were restricted to the air. So if you enjoyed this episode, you know what to do. Leave your like, check your subscription. Thank you for staying with me until now. Just click on one of the 2 suggestions on your screen, and I'll see you in the next one. Just click, it's quick. Click and I'll see you there. I'm waiting for you, okay? Thanks. Bye-bye.